Well, good morning, folks. It's me, it's Mr. Tuttle. Back again. It's Tuesday, May 12th, something like the 500th day of the quarantine, or at least it feels that way. Um, I hope you're doing all right. I'm doing pretty good. Thank you for asking. Yeah, it looks like a nice day out. I don't know if you can see. There's my office window. Blue skies, a little frosty, but what do you expect? It's May in Michigan, right? Um, so if you're watching this video, then hopefully what that means is that you have already watched the walking video number 2, where I am kind of moving back and forth in my driveway. I asked you to do kind of the same thing that I asked you to do with the first walking video, which was to make a graph that represented that motion and then answer some questions about it. I haven't looked too closely at the graphs that you submitted yesterday, but I'll be doing that after I record this video. I did glance at a lot of them, and it looks like um, y'all have the right idea there. There were some good questions um, on the thread to the post yesterday, and so I look forward to looking more closely at that work and giving you some feedback. So, um, the purpose of these notes, as I hinted at, was to kind of summarize the important things about those graphs, to kind of answer any questions that I anticipate are still out there about what you did yesterday, and then to move a little bit more forward and get into some more specifics about graphs of motion and things like that. So, but before I get into any of that, I'm going to give myself some coffee. Right. And it looks like actually I'm going to have to erase the board. This right here, my daughter Josie, who's about to be 10, was working on some fraction stuff. Pretty intense. I'm going to have to erase that so I can do some notes on this board. So anyway, as I'm doing that, let me just say that my question to you about what is your understanding of physics, what are the things about physics that you know, and what are some questions that you have? Many of the questions revolved around, is it a science that combines with math? And I think the answer to that question is yes. Um, Something else I would say is many of the sciences, whether it's biology or chemistry or astronomy and those sorts of things, they also include mathematics to a degree. Um, but I think you could make the case that physics does so more than the other sciences. So really understanding and analyzing a lot of the things that we're going to be doing in here will require some mathematics. It's not going to be too intense, kind of maybe some Math 169 kind of stuff in this particular class. But yes, you can um, really get you can really do some interesting and serious work in physics by applying calculus and other higher forms of math with that. So um, the way I think of physics as being the study of motion. Like if you had to say what is physics in one sentence, I would say physics is the study of motion. Um, it could be the study of motion of big things, like, if I drop this eraser, what's going to happen? Um, I could think about the motion of even bigger things, like the planets as they revolve around the sun, the moon as it revolves around the earth, our galaxy as it moves outward into the universe. Um, the study of those things is physics in my mind, correct? But it's also the study of very small things. So, for example, um, the molecules in this delicious warm cup of coffee are moving around, right? That's how I feel the heat, yeah. Um, and so physics can study those very, very small interactions, things like the molecules of air that I'm breathing and so forth. Physics studies those things as well. So again, that's what I think of when I think of physics. Now, the in this class, we'll basically just be studying things like this. We're not going to be doing a lot of thinking about very small things. We'll be doing a little bit of thinking about really big things, like we'll talk about the physics of our planet and other planets in our solar system, some of the stuff about that. But anyway, I feel like I'm going off on a tangent. What you're really here for is to get those notes about graphs and equations of motion. So maybe let's just get into that. So, okay, so um, let's talk about two things. Okay, so when you're studying things that move, like for example, when you were sort of studying the way that I was moving in my basement and in my driveway, um, there are two sort of big ways that you can organize the data that you collect from that sort of situation. One is in an equation, one is in a graph. So, and then furthermore, there are two kinds of graphs that you can make. So the kind of graph that I asked you to make, or that the kind of graph that many of you did make, was what's called a position time, this marker's dead, graph. Okay, so it's a graph on which, and I know you can't see that, because I can't see that, position time graph, right? Where what you had was on the x-axis, on the horizontal axis, you were keeping track of time. And on the vertical axis, you were keeping track of position, okay? And so what you did was you said, okay, 1 second, 2 seconds, 3 seconds, 4 seconds, etc. I think you were measuring my motion in inches, but, you know, 1 inch, 2 inch, 3 inch, 4 inch, right? And what many of you recognized is, as I was moving, even though the cones were not equally spaced, when you graphed the points, they all more or less, should have lined up like this, in a line that has a positive slope going in that direction, okay? Now, of course, my motion isn't perfect. Interpreting the data from the video, sometimes, you know, if you're off by an inch or two here or there, a second or two here or there, it might not be perfectly straight, but I think, generally speaking, we could say this right here was uniform motion in a straight line, and you could tell by the fact that the graph of the position time is straight, okay? So that's one so one other thing I'll say about this, I asked you to determine how fast I walked. Some of you may have realized that how fast I was walking is the same as the slope of that line. Okay, so that's important. The slope, I'm not going to write this down, I'll just say it. The slope of the position time graph is the same as the speed of the object that's moving. Okay, kind of a big deal. All right. In walking video number 2, I didn't just walk forward, but I also turned around and walked backwards. So what would that look like? Well, I can't remember exactly what I did, but I think, you know, I kind of walked forward a little bit, and then maybe I stopped, and then I walked forward a little bit, and then I stopped, and then I walked backwards a little bit. Okay. Now this is, of course, not exactly what I did, but generally speaking, if this is position, and this is time, let's look at the different pieces of this graph. So for the first piece, this part where I begin, since the slope is positive slope means I must be walking forward, okay? Okay, and then if you look at this section here, it's just a horizontal line, yes, or a horizontal segment, I should say. What's the slope of a horizontal segment? Yep, that's correct. It is 0. So if the slope of the position time graph is 0, then that must mean I'm just straight chilling. I'm not moving from this time to this time. Okay? So 0 slope means no motion. Okay? Start moving forward again, maybe at a slightly different speed. Again, I stop. This is flat, so that means there's no motion. 0 slope equals 0 speed. And then here, I start moving again, but the slope is negative. And since the slope is negative, what that must mean is I am not moving forwards, but I am moving backwards. Okay? So I think there was a question about that. How can you tell by looking at the graph when someone is moving forwards versus backwards? Well, the answer to that is what's the slope of the position time graph? Okay? So hopefully that kind of makes sense. We're going to talk about a different type of graph in just a second. Actually, what I think I'm going to do is pause this video right now because it's already getting a little long. You can sort of summarize your notes, take a look at your notes from this little discussion, and then I will put part 2 up next. Cheers.